Research design refers to the planning of a study, including how participants are assigned to different study conditions. Experimental designs involve the randomization of participants to study conditions. There are several types of experimental design, four of which are pre-test, post-test control group design, post-test only control group design, Solomon four-group design, and randomized study design, such as the stepped wedge, multiple baselines, and randomized controlled trial. Pre-test, post-test control group designs involve a control group or treatment group. Both groups complete a pre-test, but only the treatment group receives the treatment under study. Both groups then complete a post-test. Post-test only control group designs are different in that study participants do not complete a pre-test. The Solomon four-group design combines both designs into one, allowing for comparison against four groups to control for potentially confounding effects from the pretest. Randomized study designs such as the stepped wedge, multiple baselines, and randomized controlled trials are robust to threats to validity by randomizing participants to either treatment or control groups. Experimental designs can control for and eliminate most of the threats to internal validity. That is, they can eliminate many alternative explanations for the observed outcomes of a study. In healthcare research, experimental design is traditionally considered a gold standard for evaluation. However, employing a true experimental design to evaluate a program may not be feasible. For example, in some experimental designs that compare a treatment group with a control group, the subjects randomized to the control group would not receive the treatment. This practice of withholding treatment from the subjects in the control group may not be ethical if the treatment is believed to have potential therapeutic effects based on the best available evidence. An alternate approach is to compare the observed results from subjects who receive the treatment or intervention to the results that you would expect if the intervention had not been implemented, again based on the available evidence. The latter condition is the counterfactual condition. It relates to what has not happened, or in this case, an intervention that has not been provided. To definitively evaluate impact, it has been argued that it is essential to estimate a counterfactual outcome, that is, a reference point based on what has or would happen in the absence of the intervention. Some people, however, argue that in complex dynamic situations, such as healthcare contexts, it is nearly impossible to soundly evaluate what would have happened in the absence of an intervention, given that this absence would have affected the situation in ways that cannot be predicted. In an effort to develop a valid counterfactual outcome for study design, evaluators could develop a hypothetical prediction of what would have happened in the absence of the intervention. This can be accomplished by asking experts in these types of programs or in the community to predict what would have happened in the absence of the intervention, using the baseline as an estimate of the counterfactual outcome, since it is the point before any effects of the intervention program would be expected, or using the baseline data and process tracing. Process tracing is a case-based approach to infer cause by using clues or observations within a case to outline possible alternative explanations.